Good morning, class. We are looking at chapter 3 derivatives. Here's section 3.5, the chain rule. So we covered derivatives and rates of change, the derivative as a function, basic differentiation formulas, product and quotient rule, and now the chain rule. So we start with the composite function, y equals f of g or f of g of x. Now y prime is f of g prime, which makes f prime of g of x times g prime of x. Understand, f is the shell, the outer function, g is the inner function. In a Leibniz's notation, dy dx is dy du, du dx. So, reminding you of differentiation formulas starting with rise over run. You have the blue line, the secant line, you have 2 points. You can calculate the slope in different ways. And if you look at f prime of a as a limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0, you are coming up with the slope of a tangent line, the red line at point A, giving formula for the equation of it. Now, so dy dx is limit of delta y over delta x as delta x approaches 0, or f prime of x is limit of f of x plus h minus f of x over h as h approaches 0. That's the definition of differentiation. The derivative of x is 1, the derivative of c times f of x, c comes out, and the derivative of the sum is the sum of the derivatives. The derivative of the difference is the difference of the derivatives. And we have looked at some differentiation rules. The derivative of a constant is 0, kx is k, e to the power of x is itself. The derivative of sine is cosine, cosine is negative sine. Tangent is secant squared, cotangent is negative cosecant squared, secant is secant x tan x, and the derivative of cosecant x is minus cosecant x. And these are the same rules that were discussed here. This is the product rule in a shorthand notation. Fg prime is f prime g plus g prime f. And this is the quotient rule. F over g prime is f prime g minus g prime f over g squared. And now we are adding the composite function and the derivative of a composite function. Y prime is f prime of g of x, g prime of x. The derivative of the shell function, the outer function, over the inner function times the derivative of the inner function. First, let's remind you of composite functions. The composed function f of g, the composition of f and g, is defined as f of g or f of g of x. For example, as a warm-up example, for the given function, find f of g and g of f. F of x is x cubed, g of x is 1 plus x squared. To find f of g, that means f of g of x. That means f of 1 plus x squared. And that means replace the x in f of x with 1 plus x squared. And we are done. Whereas g of f of x means g of f of x. That means g of x cubed. That means into the g function, replace the x with x cubed. And since this is easily evaluated, 1 plus x to the power of 6. As you can see, f of g in general is not equal to g of f. The composite function of the two are different. If, just reminding you of algebra, if f and g are inverse functions, f of g equals g of f equals x. The only time they become identical when they are inverse functions. Otherwise, that's not the case. Now, Why do we learn the chain rule? 3.5, the chain rule. How would you differentiate composite functions such as y equals square root of 10x plus 5 or f of x equals 10x squared minus 1 to the power of 50? That's why we go with the chain rule. If g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. d dx of f of g of x is f prime of g of x times g prime of x, meaning when you're given f of g of x, differentiate the outer function over g of x times the derivative of the inside. In Leibniz's notation, y is a function of u is a function of x, dy dx is dy du dx. Notice this is still dy dx. So to recap that, if we call capital F of x is f of g of x or f of g of x, then capital F prime or the derivative of this composite function becomes f prime of g of x times g prime of x. Again, f is the shell, is the main function, is the outer function. So take the derivative with respect to g of x and then times g prime of x. This is the chain rule. And so, for example, when we look at the power rule, the derivative of x to the power of n is nx to the power of n minus 1. In the case of the extended power rule, also known as the general power rule, if instead of x we have g of x to the power of n, notice we have the same n, x to the power of n minus 1, in this case is g of x to the power of n minus 1, and then by the chain rule, the derivative of the inside is g prime. Remember, when you differentiate x to the power of n, the derivative of x is 1. So if I write times 1 makes no difference. But now the derivative of g of x is not 1, and it does make a difference, and I must write it. This is known as a general or extended power rule, or a form of the chain rule. Now, one function that I believe makes it reasonably easy to understand the concept of a composite function would be some sort of a trigonometric function, a sinusoidal function. So for example, y equals sine 2x. It's important to understand the main function is the sine function. Okay, so the best course of action to differentiate sinusoidal functions or any trigonometric functions is to basically pause and read sine. Stop, pause. The answer is cosine. But every trigonometric function must have an argument. The argument given for sine is 2x, so it has the same argument. Now, by the chain rule, if this was x, it would be done because the derivative of x is 1 with respect to x. But now the derivative is 2, and that's why this is g prime of x. And that's the chain rule. We put the 2 in front. In this case, again, we read sine and we stop, and the answer for sine is cosine. You need an argument, you write it. By the chain rule, you need the derivative of the argument to x, and you're done. We put the 2x in front, 2x cosine x squared. And this one, perhaps if we rewrite it as sine x to the second power, and so we notice we are going to use the extended power rule, makes it easier to see. So we have a y prime, n is 2, then sine x to the power of n minus 1, and then times the derivative of the inside, which is cosine x. The derivative of sine x is cosine x, so we get 2 sine x cosine x. Understanding these three questions, I believe, makes it easier to follow the concept of a composite function. All right, we have y equals u to the power of 5, that means the function of u, and u equals 10x cubed plus 2, that means the function of x. And we want to differentiate this, and I'm going to do it two ways. I'm going to go with the Leibniz's notation. dy dx is dy du dx. That means first take the derivative of the first function with respect to u. So this is u to the power of 5, simple power rule, 5 u to the power of. Then take the derivative of du dx, take the derivative of u with respect to its independent variable, which is x, makes it 30x squared. Practically, you're done. Replace the u with 10x cubed plus 2 because you want the final answer to be a function of x, dy dx. And now times 30x squared gives us, put them in front, and 150x squared times 10x cubed plus 2 to the power of 4, and we're done. The second method is to find the composite function. And it's very easy to find the composite function. What is f of g of x? What is f of 10x cubed plus 2? That's the parentheses 10x cubed plus 2 to the power of 5. Now we are going to differentiate this using the extended power rule. So again, composite function, y prime f of g prime is f prime of g of x, that times g prime of x. So the shell function, okay? So 5 sits in front. Same thing to the power of 5 minus 1 or 4. And then times the derivative of the inside, the derivative of the parentheses is 30x squared. Just put them together and you get exactly the same answer as you got here. Let's continue with more practice. We are using the extended power. So we want the derivative of y equals 10x squared minus 1 to the power of 50. 50 becomes a coefficient. The same thing to the power of 50 minus 1 or 49. We're talking about this part. And then g prime of x, the derivative of the inside is 20x. If we put these two together in the front, we get 1000x times 10x squared minus 1 to the power of 49. Y equals square root of 10x plus 5, we are going to rewrite it in a format that power rule can be used, in fact, the extended power rule. So 10x plus 5 to the power of 1 half. And now according to this, n, so the exponent becomes the coefficient, y prime is 1 half. G of x, that means the parentheses to the power of n minus 1, 1 half minus 1 is negative 1 half, 1 half minus 1. And then finally, the derivative of 10x plus 5, meaning 10. Now clearly, we have a fraction bar. Okay. 2 is at the bottom, 10 is at the top. Okay. And then x plus 5 to the power of positive 1 half. So 10 and 2 cancel each other. The numerator becomes 5, and this one we put it back in the same format. So 5 over square root of 10x plus 5. It's important to put it back in the same format. Y equals 5 times 3x minus 2 to the power of 4. So 5 is a coefficient. It doesn't go away. So you're differentiating this part using the extended power rule. This is the part we are going to work on. So 4 becomes a coefficient. Same thing, cubed, because 4 minus 1 is 3. G prime of x, the derivative of the inside is 3. We're done with calculus, 5 and 4 and 3. The product is 60. We put it in front, and we're done. Now, we want to take the derivative of y equals e to the power of 10x, reminding everyone that the derivative of e to the power of x is itself. Also reminding everyone that the derivative of f of g of x is f prime of g of x times g prime of x. So if you happen to have e to the power of g of x, according to the exponential rule, the answer is itself. According to the chain rule, times g prime of x, because this one, the derivative of x is 1, so times 1 makes no difference, but now it does make a difference times g prime of x. And if it happened to be any function, you take a derivative. For example, if it's e to the power of kx, obviously the derivative of kx is just k, so e to the power of kx times k. So the way I do exponentials, everybody, I just write the function itself first. And I look at the exponent is x, I'm done. If it's not, I just tag along its derivative and I rewrite. I want to take the derivative here. I just write the answer as it's saying. Why? Because it's exponential. It's a function of t. Is this t? No. It's a function of t. So by the chain rule, times 2t, remember g prime of x, g prime of t. Okay. So we get 2t e to the power of t squared. We put the 2t in front. Now, you can differentiate it the way it is. However, I hope everybody recognizes this as e to the power of t times 2, or simply 2t. So y prime is itself times the derivative of 2t, and we rewrite it, we're done. Differentiate y equals 5x times 3x minus 2 to the power of 4. I want to make a point of this number. Class, if this number is huge, like it's 5,000, or if it's involved, it's like decimal, 1.5821, or if it's a fraction like 2/3, then you want to put brackets here and just carry the 5 in as a coefficient, as a factor. And I'm going to show you that method. But in this case, really doesn't make any difference because 5 is not that big of a deal. So you can think of it in the following manner. Say this is the f function. Okay. This is the g function. And use the product rule. F prime g plus g prime f. F prime is 5 times g, 3x minus 2 to the power of 4, plus g prime. Now this uses the extended power rule, plus 4, and g of x to the power of n minus 1 this thing to the power of 3. And then times g prime, the derivative of the parentheses times 3. Going back to the product rule, this is g prime f times 5x. Okay, we're done with calculus. Let me just make sure we understand what's happening here. Of course, we have. So this is it. You're done with calculus here. Okay, everything else is algebra. So 4 and 3 and 5 is 60. We put 60x in front. Just this part, we are going to simplify to this one. So we no longer need this one. We are looking at this one, okay? And we're going to factor what's in common. Obviously, 5 and 65 is in common. 3x minus 2 is in common. Exponent 4 versus exponent 3. We use exponent 3, the smaller of the two. Again, I'm just doing simple factoring. Divide this one by this one, you get 3x minus 2. Divide this one by this one, this completely goes away. 60x divided by 5 is 12x, and 12 and 3, they add up to 15x. So you write 5 times 3x minus 2 cubed times 15x minus 2, and you're done. And notice this 5 carried from the get-go. Now I want to show you again, if this is involved and you want to separate them, what happens? I'm not going to finish it, but I'll show you the first step. So this means, first and foremost, you separate them in this fashion. You put brackets here. And now if you're differentiating, 5 remains. 5 doesn't go anywhere. Okay, so you have the 5. Now, this one now, class, I'm going to write, this is F. This is G. In which case, F prime is now 1 times 3x minus 2 to the power of 4. So this is 5. So 1 times 3x minus 2 to the power of 4 plus G prime. Now G prime is the same thing that we found here, 4 times 3x minus 2 cubed times 3x. Instead of 5x, we're going to multiply by x. Again, we carry the 5. X, the derivative is 1, 3x minus 2 to the power of 4. Plus G prime, the same thing here. Instead of 5x, we're going to multiply by x. If you continue finishing it off, remember the 5 remains and it works out. Again, I don't think it makes much of a difference in this case, but it does make a difference in other cases. Now, what about this one? You bring it up so that you can use the extended power rule. And how do you bring it up? You remember the negative exponential rules. A to the power minus n is 1 over a to the power of n, or vice versa. 1 over a to the power minus n is a to the power of n. You move the exponent and you change the sign. So with that being the case, I'm going to go with the extended power rule. Y prime is n, which is negative 4, times the same thing to the power of, subtract 1, you get minus 5. This is minus 4 minus 1. And finally, G prime, the derivative of the inside is 14x minus 1. So you have a fraction bar. This number is at top. This is at top. This one goes down. Negative exponent becomes a positive exponent. The final answer minus 4 times 14x minus 1 over 7x squared minus x to the power of positive 5. Differentiate. Well, we have to go with the quotient rule. And the chain rule as well. So first, we need f prime, which is 1, times g, which is 2x minus 1 to the power of 4. I'm looking at this part. Then I need minus g prime f. G prime uses the extended power rule. That's the chain rule. So minus g prime minus 4 times 2x minus 1 cubed times the derivative of the inside 2. This is g prime times f which is x. And then you put the bottom here, and the exponent is 8. And we are going to write, this is f prime, this is g minus, this entire thing is g prime f over g squared, and done with calculus. Class, this is the only calculus step. We are done. So what do? We finish the job by factoring the common factor of 2x minus 1. Let me erase my work. 2x minus 1 is in common. This was as exponent 4, but this one has exponent 3. So 2x minus 1 cubed is in common. So we put the brackets. We divide this one by this one. That results in 2x minus 1. We divide this one by this one. This is completely gone. 4 and 2 and x is 8x minus 8x. And so 2x minus 1 cubed completely goes away. 8 becomes 5. And these two combine into negative 6x. This doesn't change. So minus 6x minus 1 over 2x minus 1. It's that simple, everybody. So one step of calculus, a number of steps of algebra. All right, the very first step is to rewrite this as x squared plus 3 to the power of 1/2, bring it up to the power of negative 1/2. That's your first step, everybody. And now we are going to use the extended power rule. 4 is not going anywhere. N negative 1/2. G of x to the power of n minus 1, the same thing to the power of minus 1/2 minus 1 becomes negative 3/2. The derivative of the inside is 2x, and we're done. With calculus. Here's the calculus step, and we are done, everybody. Calculus step. Everything else is algebra. So 4 and negative 1/2 is negative 2. And 2, negative 4x. This one goes down, becomes positive 3/2. And you put it in the same format, becomes negative 4x over the square root of x squared plus 3 to the power of 3, just to have it in the same format, everybody. When you do sinusoidal functions or any trigonometric functions, I'm going to underline cosine, and I'm going to pause. Cosine. We know the derivative of cosine is what? Negative sign. I'm going to put negative sign. However, you can't write any trigonometric function without its argument. So I must have the same argument. And then by the chain rule, I need to have the derivative of that, which is 12t cubed. Now you can look at this one, d dx of cosine u is minus sine u du dx, or d dx of cosine of g of x is minus sine g of x g prime of x, in this case minus sine g of t g prime of t. You put the 12t cubed in front, and that's the final answer. So minus 12t cubed sine of 3t to the power of 4. Anytime you want to differentiate a rational function or any function that is in the form of a fraction, the first question is, can I simplify it? And the answer is yes. You have two choices. You can either factor the x from the top, and the x cancels out the x. Or say I make up this fraction and this fraction, two fractions, and do the math. Either way, when the bottom is one term or one algebraic expression, you must simplify it. And this follows the extended power rule in, which is 6. G of x to the power of n minus 1, x plus 4 to the power of 5. And then by the chain rule times the derivative of the inside, it happened to be 1, and therefore we are done. Y equals 2x plus 3 over x minus 8 to the power of 5. We are going to use the extended power rule in conjunction with the quotient rule. So n is 5. G of x to the power of n minus 1, this whole thing to the power of 4. And now g prime, that means the derivative of the inside, we are going to go with the quotient rule. So we're going to use f over g using the fact that the top, we're going to call it f. So f prime g minus g prime f over g squared, and the bottom is g. So the derivative of the top is 2 times the bottom x minus 8 minus g prime minus 1 times f, the numerator is 2x plus 3 over g x minus 8 quantity squared. And we're done with calculus. Again, let me put an asterisk next to it. This is done, everybody, with calculus. Now we are going to use our algebraic technique to finish it, which means first we're going to distribute 2x minus 16 minus 2x plus 3, and these two cancel each other, the other to add up to negative 19. So right here, you can write the final answer, but just in case I don't want anybody to make a mistake, I'm going to rewrite this part as 2x plus 3 to the power of 4 over x minus 8 to the power of 4. This is 5, this one, and I'm going to write the last one. Now notice 5, 2x plus 3 to the power of 4 and negative 19 belong to the numerator. So the product of these two is negative 95 times 2x plus 3 to the power of 4. Product of these two is x minus 8 to the power of 4 plus 2. And the reason I wrote that, because I don't want anybody to think that x minus 8 has an exponent 1. It has exponent 4. All of these are exponential functions. And as we explained for the exponential functions, first you just write what you see. Anytime you're dealing with the exponential function and you want to differentiate, just write that. Based on the chain rule, you need the derivative of the exponent, and you put the 5 in front. In essence, you're using this, or you can say this one. Part B, y prime is itself e to the power of tan x times g prime of x, the derivative of tan x, secant squared of x. And we're done. We don't have to write it in front. That's good enough, and we're done. Now, part C, you don't have to do much. I want to make sure that you see that this is e to the power of 2/3 x. That's why I rewrite it. And then y prime is the same thing. Times, you can use that one or the next one. The derivative of this is 2/3. You put it in front. Whether you use e to the power of 2/3 x or the same format, e to the power of 2x over 3, as long as you recognize the coefficient of x is 2/3, you're fine. As we mentioned before, the derivative of e to the power of x is itself, and we want to find the derivative of y equals 3 to the power of x. We know the derivative of e to the power of x is itself. E to the power of kx is itself times k. E to the power of g of x is itself times g prime by the chain rule, but we never dealt with a base other than e. The question is, how do you do that? Well, let's look at the general format. Y equals b to the power of x. The base is no longer e. Reminding you of a couple of logarithmic properties. Ln of e to the power of x is x, e to the power of ln x is x, and we are going to use this format and replace the b with e to the power of ln b. E to the power of ln x is x, so e to the power of ln b is b. But now if we replace it, remember ln b is just like any other number, like k, okay? So we're going to write it in this format. E to the power of the product of ln b and x. And again, this ln b in essence is k, everybody, is a number. ln b is a number. So the answer is itself times k. The answer is itself times k, or ln b. So same thing times ln b. Now the same thing, we go back here, we can replace it by b to the power of x. So let's do that. So this thing is b to the power of x, right? So write b to the power of x times ln b. Therefore, if you want to differentiate this, the moment you see an exponential, you say the answer is itself. Then you investigate further. Is the base e? No. So you need ln of 3. Is the exponent x? You're done. If not, you have to use the chain rule. Now, we keep it in the same format because if you put this in front, you may be confused with ln of 33 to the power of x, so we're done. What about y equals 2 to the power of 7x? We tag along the chain rule. So if we have a b to the power of f of x, the answer is b to the power of f of x times ln b, because the base is not e. That's because of logarithmic properties. F prime of x, because of the chain rule. So the answer is 2 to the power of 7x. Since the base is not e, ln of 2, since this is a function of x by the chain rule, its derivative times 7. And the way we rewrite it, we put y prime is 7 ln 2 times, we put it in a parenthesis, times 2 to the power of 7x, because for sure we don't want to think it's 22 to the power of 7x, so we have to separate it in this fashion. All right, let's look at some applications. After T weeks, the number of people using a new rapid transit system was approximated by the formula n of t equals 6t squared plus 500t plus 8,000. At what rate was the use of the system changing with respect to time after 8 weeks? Because one point in time is given, that means instantaneous rate. That means take the derivative. 12t plus 500. Replace the t with the given number 8. 12 times 8, 96, and 500 is 596 people per week. Why is this people per week? If you look at the Leibniz's notation, dn dt, the change in n, the number of people, over the change in time in weeks. What does it mean? On or after week 8, the number of people using the transit is increasing, at the rate of 596 people per week. Why increasing? Because this number is positive. What if it were negative? You would just write decreasing, you wouldn't change this. Whether it's positive or negative, you write this number as positive. Increasing means positive, decreasing means negative. A bacterial colony is estimated to have a population of P of t equals 24t plus 10 over t squared plus 1 million t hours after the introduction of a toxin. What is the population after 1 hour? So that means plug in 1, elementary algebra. Again, if they said what is the population after the introduction of a toxin, that means t is 0. But they give you time, then you plug in the time. So 24 times 1 plus a 10, that's 34. The denominator is 1 and 1 is 2. 17 million bacteria. At what rate is the population changing 1 hour after the toxin is introduced? Rate and only one point in time, that means instantaneous rate, that means P prime of t, take the derivative. And when you go back to P of t, notice you have to use the quotient rule. So we are going to call it F over G, where F is 24t plus 10 and G is t squared plus 1. So F prime 24 times G t squared plus 1 minus G prime 2t times F 24t plus 10 over G t squared plus 1 squared. And you're done with calculus. Everything else is algebra. To simplify this, distribute the 24t squared plus 24 minus distribute the 2t minus 48t squared minus 20t. You can combine these two into negative 24t squared, and we write the rest in descending order. This is P prime of t, but we want P prime of 1. So let's plug in. We are going to replace the t with 1, everybody. P prime of 1. When we do that, we get negative 24 minus 20 plus 24. This is 1. And the numerator is simply minus 20. The denominator is 2 squared or 4. We get minus 5 million bacteria per hour, because P prime of t means dP dt. When we write it in Leibniz's notation, we can see the units dP, change in population, millions of bacteria, over change in time in hours. So minus 5 million bacteria per hour means what? The population of bacteria is decreasing at a rate of 5 million bacteria per hour, 1 hour after the toxin is introduced. In other words, this negative sign is taken care of by this word decreasing. You don't repeat that here, because if you do negative times negative, makes it positive in essence. Example 3, observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age t in days by the function w equals 3 plus 0.21t. How long is the tiger? When it's 100 days old. Of course, kilograms is about 2.2 pounds. So we have two choices. We can find the composite function L as a function of t, or we can work on it just the way it is. We are going to plug in 100 here to find the weight after 100 days old. And 0.21 times 100, two decimals and two zeros cancel each other. So this is 21. And plus 3 gives us 24 kilograms. And now if we put this into here and put it into a calculator, so 0.25 times 24 instead of the weight, the power of 2.6, put it into a calculator, you get 969.369 millimeters, reminding everyone that 1 meter is 100 centimeters or 1,000 millimeters. So that means this is almost 1 meter. At what rate is the length increasing when it's 100 days old? Rate and 1 point in time, that means differentiation. So we want dl dt. I'm going to go with the Leibniz's notation. As I mentioned, the second method is to find the composite function. We'll discuss it in a moment. So we want dl dt. The way I'm going to write it, I'm going to write dl dt. Look at dy dt. You have dy du dt. So if you write these two just the way it is here, nothing has changed. The point is, what is u? Y, how does y get to t? The intermediate variable is u. How do we go from L to t? L to t, the intermediate variable is w. So dw, dl dw, dw dt. Now, what does this mean? This means differentiate this with respect to w. W is the independent variable here. So 0.25 times 2.6, w to the power of 2.6 minus 1 or 1.6. That's dl dw, everybody. This part. What is dw dt? It's just 0.21. So dw dt is just 0.21. Multiply 0.25, 2.6, and 0.21, and you get 0.1365 w to the power 1.6. We have two choices. We can replace the w with its function. If they have asked for the function, you must. Or t is 100, and when t was 100, we remember w was 24, just replace it with 24, and you have the answer for here. Put it into a calculator, and it gives you 22.0532 millimeters per day. By the way, the number of decimals, carry out a lot of decimals unless they ask you how many. And normally in a case like this, because all the formulas are estimations, they will tell you. Now, I went with the Leibniz's notation. This is simple enough that you can find the composite function. So I want to show you the second method. By replacing this into w, you get L of t equals 0.25. This one, 3 plus 0.21 t to the power of 2.6. This is method 2. So for part A, replace the t with 100 because we want the length of the tiger after 100 days. And we get this much. Using a calculator, plug into a calculator, and of course you get the same answer as this. The second part, part B, you want to take the derivative. So L prime of t, or dl dt, it's 0.25 times, we're looking at extended power rule, times n, which is 2.6, times 3 plus 0.21 t to the power of 2.6 minus 1, which makes it 1.6, and times the derivative of the inside, which is 0.21. To recap, 0.25 remains. 2.6 becomes the coefficient. Same parentheses, you write it. The exponent 2.6 minus 1 becomes 1.6. The derivative of the inside, this is g prime, is 0.21. Multiply these three numbers and you get the same thing as you had here. These two are identical. This is function of W. If we had changed it to 3 plus 0.21t, we would have got that. Okay. And now if I replace this t here with 100, I get the same answer, which means the rate of the Siberian tiger is increasing on day 100 or after it's 100 days old at a rate of 22.0532 millimeters per day. Why is it increasing? Because this number is positive. This number is positive. So pretty straightforward. Example, for the amount of glass recycled in a community is G of P equals 0.5 P squared plus 7 under the radical tons, or square root of that, where P is the population in thousands. It is estimated that T years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared thousand. How many tons of glass are expected to be recycled 4 years from now? Again, this has two ways. I'm going to stick with the Leibniz's notation, and that means for this part, I'm going to just replace the T with 4. (16 times 0.1 is 1.6 and 4.4. They add up to 6. And that represents people, 1,000 people. 6,000 people. Now, what about the amount of glass? Replace the P with number 6, and we get 0.5 times 6 squared is 36. Half of it is 18, plus 7 is 25. The square root of 25 is 5 tons of glass. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. Include units in your answers. Now, rate and 1 point in time, that means differentiation, and we want the change in glass, right, with respect to time, dg/dt. So we're going to write dg/dt again. But what variable takes us from g to t? The intermediate variable p. So dg/dp, dp/dt. I'm going to erase my work because I want you to see that in order to differentiate this, I'm going to rewrite this to the power of 1/2. And so I can use the extended power rule on that, which means 1/2 times 0.5 p squared plus 7 to the power of negative 1/2, right? 1/2 minus 1. Then g prime, the derivative of the inside is 0.5 times 2p, or simply p. I want to make sure we understand this one more time. 1/2 sits in front. The same thing we write it. The power of 1/2 minus 1. 1/2 minus 1 is negative 1/2. Then the derivative of the inside is 0.5 times 2p. This is 0.5 times 2p, or simply p. And then dp/dt. dp/dt is 0.1 times 2t, or 0.2t. So right here, from the previous part, you can replace the p with 6 or t with 4, but let's simplify it a little bit. So you see a fraction. The bottom is 2. This one has exponent negative 1/2. Goes down. Goes down. Take a positive 1/2 as an exponent, and it becomes a root. So this goes down. At top, we have 1. We have p. We have 0.2t. So at top, we have 0.2 pt, and the bottom is 2. With this thing, that was a square root. Now, you have to replace the p with 6. T is 4. So 0.2 times 6 times 4. This one, we've already calculated right here. When I replace this P with 6, we ended up with 5. So this one, we know it's 5. We've already calculated it, everybody. So again, 0.2 times P, which is 6, times T, which is 4. 2, we've already done this, so we are going to use the fact that we've already done that. That's 5. So the denominator is 10. The numerator is 4.8. 0.2 times 6 times 4. And 4.8 over 10 makes it 0.48. And what are the units? dg dt, units of G over units of T, tons of glass per year. Tons of glass per year. What does it mean? 4 years from now, the amount of glass recycled is increasing. Why increasing? Because this is positive. At what rate? This rate, 0.48 tons of glass per year. So very straightforward, everybody. The second method is to replace the P with this. So write G of T is 0.5. Instead of P, you're going to put 4.4 plus 0.1 T squared to the second power. Okay. Plus 7. The second power is because P squared. Now, I'm not going to work on that. You're more than welcome to work on it at home. But I want to make a point. This is a tad more difficult than this because of the nature of the function. That's why it's important to know both methods, and you work with the method that is easier for you.